Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue chapter Chem. In this lecture, we will continue our examples of Chem profile, but in last example we have completed simple means without offset. Now we are going to we take one numerical with offset, which is more complex than our last. Okay, so as you can see the given data here, so Chem is given to the Chem is to give the following motion. Knife edge follower is there. In last example we have completed Chem profile with knife edge follower, but there is a no offset is there, but in this example there is a offset. Okay, outstroke means lift or stroke or rise is 60 degree. After that dwell for 30 degree. After that return 60 degree. And remaining dwell for 210 degree. So this total will be always 360 because all data is given for that one revolution, one complete revolution of Chem. Okay, the stroke of the follower is a 40 mm. Okay, rise is a 40 mm is given. Minimum radius of Chem is a 50 mm, means base radius or minimum radius is a 50 mm. The follower moves with a uniform velocity during both outstroke and return. So the type of motion for displacement diagram we have to consider as a uniform velocity. Okay, and draw the profile of Chem when axis of follower is offset by 20 degree. Remember that this example is totally different because the offset is a 20 degrees given from the axis of the camshaft. From the axis of the camshaft. In this example, the direction of Chem clockwise or anti-clockwise is not given. So we are assuming that Chem is rotating in a clockwise direction. So profile we will making in this example will be in anti-clockwise, because always make profile in opposite direction in of rotation of Chem. In this example, this is direction is not given, so we have taken that as a clockwise and profile will be anti-clockwise. Okay, let's start. So first of all, write down the given data. Okay, so you can check here the given data already given. Lift is a 40, here stroke is a 40, minimum radius is a 50, so minimum radius base radius is a 50, and all angles 60, 30, 60 and 210 all will be considered as a angle theta 1, 2, 3 and 4. Okay, and other points we have to always find in a given data, which are the knife edge follower, uniform velocity is types of displacement diagram, offset is given, and we assume the direction of Chem in a clockwise direction. Okay, so these four data also very useful during the drawing the profile of Chem. Okay, let's start. So these are the data we already know. Now first of all we have to make displacement diagram as per uniform velocity, and you already know that how we can draw the velocity displacement diagram. There will be rectangle whose length will be 18 and height will be depend on the rise or lift. Lift is a 40, so 4 centimeter, because we have taken the scale 20 degrees equal to 1 centimeter. In all example we repeat this procedure, scale 20 degrees equal to 1 centimeter, and partition of this rectangle in 4 parts, and like 60 degrees equal to 3 centimeter, 30 degrees equal to 1.5, 60 is equal to 3, and 210 is equal to 10.5. So this is the distance. We divide this rectangle here. So check this. First of all 3 centimeter, 1.5 and 3 centimeter. Consider remaining as a 10.5, and after that what we are going to do, we are dividing this rise in another 6 parts. Okay, 6 parts of this rise, equally 6 parts of this return. And in uniform velocity, very simple method is there. We have to just make the line from this point. This is the dwell, this is the return, and this is again dwell. This green line indicating the displacement of follower, and we are going to all the notation here 0 to 6, 0 dash to 6 dash, ABCD up to G, and then up to P at the end point. Okay, so it is already we have practiced. So this is the displacement diagram for this given data. You can check here 60 degree is given, 60 degree, so 60 degree, 30 degree, 60 to 10. Height will be 40 because lift is given 40 here. Outstroke, dwell, return, dwell, and for uniform velocity the line is this displacement diagram is very simple, straight line. Connect corner of this rise and return and you will complete the displacement diagram. But now we are going to start the cam profile, and there is a very few points are there we have to must consider during the cam profile, otherwise there will be mistake can be happen. Okay, let's start. So first of all we have the base circle radius. Okay, so first of all make the circle size of 5 centimeter. Okay, this is the 5 centimeter circle. Okay, and if there is a offset is not given, what I am going to do if offset is not given? If offset is not given, I am start with this center line and partition of this circle. But if offset is given, we are going to make another circle with the same center, which radius will be same as the offset. Okay, offset is a 20 mm is given, so we are going to make another circle at a center. Okay, and radius of this circle will be same as the offset. After that I will draw the tangent line, or I can say, so let's start. Okay, first of all we have to make horizontal line at a center up to offset circle, and then vertical line. Okay, draw the vertical line, and then we are going to obtain this point here, which is very important. This point you can see here, this point here, and connect this point to the center. We are going to connect this point to the center, and remember that this line, okay, remember that this is very important line because this is a reference line, and with respect to that this line we are going to divide this circle, okay, in 4 parts. Which 4 parts? Already we know that 60, 30, 60 to 10. But with respect to this line, if offset is not given, I am going to draw this base circle, and first line is our reference line, and all angle I am making with respect to that. But if the offset is given, if offset is given, if offset is given, first circle will be the base circle, and inside that there will be offset circle. It is known as a offset circle, and I am going to make one horizontal line and then vertical line, okay, intersecting the base circle. And this point is very important for me because I will connect these 2 points, okay, and this line will be reference line, and all angle I will measure with respect to this line. Okay, so let's start. Divide this circle in these 4 angles, 60, 30. Okay, so but remember that whenever you dividing this circle in these 4 parts, theta 1, 2, 3, 4, don't extend that line out of circle. Okay, make this line up to the base circle only. So this is the 60, 30, and then okay, I have divided this circle in these 4 angles, 60, 30, 60 and 210. Okay, and after that you know that we are going to divide this rise and return in 6 parts. So I am going to divide this rise and return in a 6 parts like I'm going to give you, but don't make the lines here because we are going to make tangent only. Okay, first of all I will divide this in a 6 parts by using protector. Okay, so I have divided this rise and return in a 6 part, and now I am going to draw the lines. But remember that in offset we are not drawing these lines with respect to center. We are going to draw that tangent, because you check this first line is a tangent with this. So all lines will be tangent which pass through the point and should be tangent with the offset circle. Okay, so make these types of tangent which are passing through the point and simply tangent at a circle, and that's how you will get all points. Okay, which points? Check this here. This is the, you know that this is a starting point of 0. Here will be your starting point 0. After that 1 2 3 4 5 up to 6. So you can get here, you will get here what, 1 2 3 4 5 and 6 is the last point. And same as for return, your tangent will be same like this, which must all pass through these points and should be tangent perfectly. Okay, that's how you will draw all tangent and you will get the points. But after that, what you are going to do, you have this distance, you know that this distance 1 to B. So from this one point you will get this point here, like A is here, B, C, D, E, F and G. You will measuring this distance 6 to G distance, and you are applying this distance from here. Okay, same start will for that and here, and it will decreasing slowly and you will get here. So this is your profile. Now you have to connect all points here like this and you will get the profile. And after that you have to make here knife edge follower also like this. So this is your offset profile. Okay, let's check this, and that's how you will complete this. I am revising it again. So first of all, make this circle here. First circle will be here, offset circle. This is the base circle. Make the horizontal line, then vertical line. Okay, and connect this line with center, and it is your reference. After that you are making the all angle like this, 30, 60 and again 60. This 4 partition of as per given data, and then all should be tangent here. Okay, all should be tangent, which are you making with this offset circle, and pass through all points. You will draw this cam profile. Okay, thank you.